Hey everybody, this is Alan. I was asked to do a quick little tutorial on factoring, so I wanted to go ahead and go through some of the rules. There's virtually only three of them. The first being GCF, meaning greatest common factor. So factoring is just a way of dividing to multiple things, and we want to find all the things that they have in common that we can factor or divide out. And we would like it to be the greatest or biggest amongst all of the terms so that we can just make it as simple as small as possible. Now, whether you have that or not, do it, then move to number two. Number two, you're going to attack it based on the number of terms. And this is probably the most important. It's not the most important because of being number two and not number one, but we do attack differently depending on how many terms we are given. So with that being said, there are several different techniques. First and foremost, the easiest one is when there are two terms. That is called the difference of two perfect squares, or in short, difference of two squares. And that is when we just have a plus b in one factor and a minus b in another. And I'll go over all of this with some examples. You cannot factor when there is a sum of two squares. There's no way to break that up and have it be anything, whether it's two positives or two negatives, that when you FOIL distribute everything out, you would get this. Therefore, we say when something is not factorable, it is prime. There are, however, two different techniques when it is cubes. When it is a cubed or b cubed, and again, a and b just stand for anything, could be multiple things. But when something is cubed, if it's adding or subtracting, then you can use this little acronym SOAP to help you for the same, opposite, and always positive for the last, depending on what's here. So same meaning, if it's plus, then you're going to have a plus, opposite, minus, and then again, always positive. Now, if it were a minus sign instead of the two cubes being separated by a plus, we would call it the difference of two cubes. Now it would be the same, opposite, and again, always positive. And notice what goes in the first slot is a binomial where your thing that is being cubed first goes in the first slot. Whatever's cubed in the second goes in the second. Then in the other factor, it's going to be the first term squared and the second term squared at the ends. And then in the middle, again, remembering that opposite sign of what you had previously, you will just take the two things and multiply them together. Again, this doesn't come up much, but it is something that you should know. The one that comes up the most besides the difference of two squares is when we have three terms. This, if I had to say any one that you need to know the most, frequently seen, it would be this we call a trinomial. Sometimes it has a leading coefficient of 1 with the x squared. Other times it can be something and therefore anything. So the only difference in doing this is when we FOIL and distribute this out, we will now have a middle term rather than them canceling out. So again, we will just think about this working in reverse. The fancy math term we use for that is inverse. And I'll go over some examples of that as well, where the signs really matter on what we put in between our factors. And the last one is when we have four terms. Can be four or more. Again, this isn't one that we see very widely. If I'm going to make sure I know one of these, it is that one. And then with the two, difference of squares. Right? But grouping, you'll literally just do that. You will group the first two terms plus the last two terms. Even if there's a minus in front, make sure that you include it and put a little plus sign in between. All right? That is the number one, even though it's number two, important thing in order to factor. Just don't forget, sometimes you're able to factor more than once, so make sure that you factored completely. Other than that, let's get to it. I'm going to start us with some distributing, in order to see what we're going to do, which is just the reverse or inverse in factoring. So you know how to multiply. We're just going to start by multiplying the x to both of the first two things. So an x times an x is going to give us x squared. X times 3 is a positive 3x. Then we will secondly distribute the 2 to both of those terms. Again, this is just distributing. Some people like to use FOIL. Some teachers even do the box diamond. Don't worry about those things. Those are just gimmicky things that don't allow people to truly understand these, which is probably why you're watching this video. So you're just multiplying, you're just distributing, but to more than one thing with more than one thing. So first we did the x to the x and got x squared, then the x to the 3, which then gave us 3x. Now we're doing the 2 to the x and the 3, which gives us another 2x's and a positive 6. And then as always, we like to simplify things, which the only things that we can make look simpler is the 3x's plus the 2x's to give me a total of 5x's with our x squared and our 6. And that's it. So we'll go through the motions with these other ones as well, making sure that we know how to FOIL or distribute, multiply 2 binomials, and then we'll learn how to undo it, called factoring. And notice how we got almost the same thing. The one thing that does differ between the x squareds and the 6's are their signs, but most importantly are the sum in the middle, the 5x in one, the negative x in another, and that has everything to do with, if you notice, the only thing I changed when we were multiplying were the signs. Okay, so the next one would look a little something like this. And notice this time our middle terms, the negative and positive 3x's, because one's positive and one's negative that we're distributing the x's to, give us 0 x's in the middle, and we're just left with the difference of 2 squares. Hopefully you're seeing that. Now, one thing you got to be very careful with, even when my calculus students are doing problems like this, they think that if it's squared, you just get to square each thing. But recall that anytime you have x plus 3 or anything squared, you have that thing times itself. In this case, twice. If it was cubed, it'd be 3 times and so on. So that means we actually have x plus 3 times x plus 3. So although some people would just square each thing and say it's equal to x squared plus 9, remember, we actually should have distributed an x to both of those, the x and the 3, and then again, the 3 to both of those. And notice, yes, you will get your x squared and 9 like we had here, but we're definitely going to have a middle part with, in this case, 6 x's. So please do not do that. My calculus students, unfortunately, continually do it because they don't know their algebra as well as they should. So those are pretty straightforward. When does it get a little bit more involved? Well, that's when we have more involved, and that is numbers in front of our x's now. Sometimes more than one. Sometimes we even have more than one letter involved, but the process does not change. All we're doing is multiplying, so we will start with the 3x as if it was the only thing there and multiply it to the other 2. Then we will take the other, which would be the 2, and distribute it to the other 2 things, again, the x plus 3. And of course, we want to continue to combine our like terms, so let's start by doing the 3x and the x. Then the 3x and the 3, and we follow that by the 2 to both the x plus 3 as well. And notice we get something very similar to above, but we this time have a leading coefficient, but still combining our like terms in the middle. So again, we're going to have a final answer that looks very similar to our others, but now it has that leading coefficient in front. Looking at the next one, again, we will start by taking the 3x and distributing it. And then we will take the positive 2 and distribute it along with that y. So that looks a little something like, and notice now we have an x times a y, which we can't actually do, so we just write it as x times y. The only thing we could do was the 3 and the -3 and multiply those to get our -9. We're just taking the x and the y and multiplying them and saying it's xy. Now for the 2y times the x, we'll go ahead and keep it alphabetical. So I will add 2xy since it is a positive 2. And then a 2y times a -3y is going to be -6. This time I have a y squared at the end, just like the x squared at the beginning. Again, I can combine like terms because remember the coefficient, the number in front, tells me how many of something I have. And since I have a bunch of x, y's in each of these, -9 here in blue and +2 here in red, that means I can combine, and what will not change is what I have, but just how many I have, the quantity. So that will give me a final answer of 3x squared -7xy minus 6y squared. So now that we know how to multiply, let's make sure that we know how to undo that, aka the inverse, and divide. Two multiple things. Let's take a look at this first one. Let's call it factoring, by the way. And we know from our experience of multiplying that this is going to just be the reverse. And because we have a 1, 2, 3, we call trinomial, then we will set up our binomial distribution, or foiling for short. So what times what when I distribute would give me my x squared. That's the first thing we're looking for. And of course, that means we are going to have an x times an x. Now, because that is the easiest thing to start with, let's go to the other end and let's look at the 6. Now, keep in mind, it is a positive 6. So what two things multiply to 6? Well, there's a couple. There's the 1 times 6, and there's also the 2 times the 3. But of course, we know from experience that we also have to combine to a +5. And because we need to make it a +6, we know that the signs have to be the same. And because we know that we have to combine to a +5, we know that they're both going to be positive. So the pairing that's going to work, that multiply to 6 and combine to 5, is a +2 and a +3 in no particular order. And that, my friends, is what we call factoring. If you wanted to check and make sure, all you got to do is FOIL it out, distribute, making sure that you get back what we originally started with. Again, just undoing the distributing or foiling with division, or a form of it we call factoring. So let's do this one as well. And notice the one thing I did change was a negative sign at the end instead of that. And because there's a negative sign, when I go to set this up, my trinomial factoring is going to be a binomial times a binomial. And we know what's going to go in the first slot to get x squared, again, is x and x. My options for that -6 at the end are 1 and 6 and 2 and 3 again. But this time, we need to make sure that we get a -1 in the middle there. And of course, it looks like it's going to be these two and not the 1 and the 6 again. And it doesn't matter where I put them, but it does matter where I put the sign. And so since we need a -1 in the middle, that means I'm going to put the negative with 3 and the positive with the 2, which again, I already know gives me a -6 when I distribute. Otherwise, I shouldn't even been talking about it. But the main thing we want to make sure we get right is the middle, which I know that a +2 and a -3 do combine to a -1. And you may be wondering, well, what about the x? We already know that that's going to give us a -3x. And that, when we distribute, is going to give us +2x to combine for the -1x that we needed for our middle. But what happens when there's not a trinomial and there's only 2? Well, remember, that is when we attack it the same way, but we only have the ends. The x squared is still going to give me my x and the x. My other end for 9, I'm thinking it's probably not 1 and 9, because remember, since there is no middle term on this one with an x, I'm going to need it to zero out. Like here, I needed it to be -1. Here, I needed it to be +5. Well, now I need something that's going to be the same so that they will zero out in the middle. And so that's why we're going to put the 3 and the 3. And of course, if we need it to zero out, that means we need 1 to be positive and 1 to be negative, so that when we do our distribution, we're going to get our x squared at the first end. We're going to get our -9 at the other end, but that's going to give me -3, and that's going to give me +3x's to cancel out and have 0 x's in the middle. Again, we like to call that the difference of two perfect squares. Right? So doing one more special case here, it is a trinomial. There is no GCF, nothing that we can factor out with the numbers. There's a 1, a 6, and a 9. And this has an x, that has an x, but this does not have any x's, so no GCF. So we say there are 3 terms. We're going to attack it with our trinomial factoring. So again, what goes first is going to be our x and x to get x squared. This time, I'm again thinking for the 9, it's probably not 1 in itself, almost always. So it's usually the other pairing. And this time, I do want to get, with that 3 and that 3, that multiplies to 9. I want to make sure that it is a positive 9. Now, it doesn't mean that that's automatically positive. Could be 2 positives, could be 2 negatives, that when I multiply together, gives me my positive 9. So to figure out the signs, we got to look again to the middle term to get a positive 6x. Both of those would have to be positive, which means whenever I have something times itself, I could rewrite that as that thing squared. And if a lot of these are looking familiar to you with what we're ending up with as answers, they should. I chose the exact same things up here. And if you notice, now our answers up here are what we are starting with down there. We're just working backwards, which again, we call the inverse or reverse. And one last scenario here. What happens, and these are what students usually struggle with the most, when there is a leading coefficient. And again, I can do more examples of these, but trying to keep this video short for you. Just a quick overview of and review of factoring. So because it is a 1, 2, 3 termed, we call trinomial, we're going to set up our binomial times our binomial again. Starting with the first term, which is a 3x squared. But this time, notice I did have to put a 3 into 1 to get my 3x squared, not just x and x. Okay? Now, with that being said, it could be a bigger number, say even a 6. Now you'd have options of 1 and 6, or 6 and 1, 3 and 2, or 2 and 3. So there are going to be various things. I'm just trying to keep it simple and get you through the process rather than all different types of examples. Now we do have a 6 at the other end, and that's where, again, we got to think, and it's not as straightforward as last time. When we put this 6, we said we had options of 1 and 6 and 2 and 3. Again, most of the time, it's not going to be the one that's 1 in itself, so we're leaning towards 2 and 3. But this time, it's not just 1x and 1x, and we're not going to just get 2 x's, and then when we distribute the other thing, get 3 x's to make either 5, or if we're subtracting, 1x. This time, we're going to have 3 times one of those things. Now remember, we should have checked first if there was a GCF, and there's almost a GCF, but because of that 11, there's no number that we can pull out or factor out of this, and because there's no other letter of x, we can't do that there either. So we know that there should not be a GCF within the problem itself if there's not at the beginning. So that means even though I'm leaning towards choosing these two to check with my guess here, I'm going to assume that if it's 2 and 3, I cannot put the 3 there, because otherwise I would have a GCF of 3, and I'd be able to pull that out, again, depending on whatever the sign is, plus or minus. Okay. So I can't put the 3 there. That means I'm going to have to put the 2 there and the 3 there to get my 6. But what I want to make sure before I even go on and start putting in my signs is I know that's going to give me my 3x squared. I know that's going to give me my 6. The one that's the hardest to figure out is the middle term, the 11. And if you notice, when I do the distributing with the 3x and the x to get the 3x squared, the 2 and the 3 to get the 6, if I do the other foiling or distributing, the 3x times 3, that's going to give me 9x's. The 2x, or excuse me, the 2 times the x gives me 2x. And when I add those, that can get me to 11x, which is what I needed in the middle. So not only did we find the pairing, but because we knew the 3 couldn't go there because of not having a GCF at the beginning, we know that the 2 has to go there and the 3 there if this is indeed the pairing that's going to work. All we got to do is be careful and make sure we put our signs same and both positive for this would work. And how do you know if you're right? Rather than plugging it into the computer or ChatGPT or whatever you might be checking your work with, you can check really quickly, even faster, I dare you. We know that's our 3x squared. You don't really need to check that. You know that's our 6. Again, you don't really need to check that. Otherwise, you shouldn't even put those there. We got this, we got that. The only part you really need to check is the 11x. And as long as you don't do the first 2 things or the last 2 things, which we know give us the first, which we know gives us the last, we just got to do the other distributions, the 3x with the 3, which is 9x, and the other pairing. That indeed would give us, because they're both positive, the 11x that we needed in the middle. And now we know for sure that this is our final answer, and we're 100% right. So let's try one more where I do have a y mixed in there, because a lot of people freak out with the middle being xy. But as long as there's no GCF, which sometimes you will be able to factor out, say a 3x, and then you're still left with the trinomial that you can continue to try to factor. But in this case, there is no GCF. Almost again, but not for this one. It's not part of the video that I wanted to concentrate on. So since it is a trinomial, we'll attack it the same way, starting with the 3x and the 1x. Again, if you want to write the 1, you can. If not, you can just get rid of it. Either way, we know it's there. All right? Now, again, I chose something easy so that we don't have to sit and guess a bunch of different possibilities. And at the end, we got our 6y squared. And our options for that, again, are 1 and 6 with the y's, and the 2 and the 3 with the y's. Oftentimes, it's going to be this, not always, but let's check. And if we choose 2 and 3, remember, we would not be able to put the 3 there because there was no GCF at the beginning. So if this is indeed going to work, the 2 has to go there, the 3 there. Just don't forget your y's to make your y squared. And we know that that gives us this. We know that that gives us this. But we do need to concentrate on the signs and make sure that you know it's a negative. And because it's a negative, that means what? Well, one of these is going to have to be positive, one negative. We just don't know if it's that or that way. So let's double check what we get. Again, don't need to check that. Don't need to check that. But what I do need to check is my middle. And when I multiply this out, I know that that's going to give me 9xy's. And that's going to give me 2xy's. And I needed to get negative 7xy's, which means I know that this has to be a negative, that has to be a positive in order to give me negative 7xy's. And the only way I'm going to get a 9xy that's negative is when I did the 3x times the 3y. That would have to be a negative. And when I did the 2xy, I needed that to be the positive. And therefore, I have checked the only part that really matters, which was the middle part. And again, I say that because we already know those. Otherwise, we shouldn't have even been putting the other things there. All right, I hope that helped. Of course, there's plenty more in factoring. You can practice on your own and let me know if you need more resources. All right, take care, everyone. Hope this helped.